To determine the appropriate tap conductor size, several factors must be considered, including the panel ampacity, the disconnect capacity, and the distance between them. In this scenario, we are feeding a 100 amp panel from a 600 amp disconnect with a distance of less than 25 feet. Firstly, we need to determine the load factor. The load factor is the ratio of the panel ampacity to the disconnect capacity. In this case, the load factor is calculated by dividing the panel ampacity, which is 100 amps, by the disconnect capacity, which is 600 amps. This gives us a load factor of 0.167. Secondly, apply this load factor to the disconnect rating. Multiply the disconnect capacity by the load factor to get the adjusted disconnect rating. So 600 amps multiplied by 0.167 equals 100 amps. Thirdly, we use table 310.16 of the National Electrical Code, NEC, to determine the appropriate conductor size based on the adjusted disconnect rating. Table 310.16 provides conductor ampacity values for various wire sizes and materials. Based on the adjusted disconnect rating of 100 amps, the minimum conductor size can be determined. For a copper conductor, a #2 AWG wire with an ampacity of 103.3 amps would be suitable. For an aluminum conductor, a #1 AWG wire with an ampacity of 108 amps would be appropriate. Therefore, for a 100 amp panel fed from a 600 amp disconnect with a distance of less than 25 feet, the recommended tap conductor size is #2 AWG copper or #1 AWG aluminum.